Hello guys, let's look at this beautiful equation. The distance traveled by a particle at nth second is equals to u plus half a into 2t minus 1. Looks good. And here is a beautiful proof for that. And there is a problem with this equation. This equation seems to be dimensionally incorrect. And let's look at why is that true. See, the distance dimensional formula is L, and the RHS side, the dimensional formula seems to be LT minus 1, which is velocity. These two things are not equal. So where exactly is the mistake is going? So to understand this, we first have to look at this thing in graphically. So I'm taking an if a distance versus time graph of a particle whose initial velocity u here taken as 1.5 and acceleration 0.1. You can change the values, but for simplicity purposes I'm taking 0.1 as the acceleration, or we can also change, let's see, 0.4 acceleration and initial velocity be 1. See, 1.8 initial velocity and acceleration 0.4, and we have to calculate the distance traveled by the particle at pth second. You see, distance traveled by the particle at pth second. So for that we have to take the p minus 1 comma p f of p minus 1. See, at pth second, and let's look at this thing. P minus 1 comma p f of p minus 1 p comma p minus 1. Look at these two dots here. The distance between the blue dot and the black dot is, the horizontal distance is 1 and the vertical distance changes according to the pth second. You see, the distance traveled by the particle at pth second is equals to the vertical distance between these 2 points. Is that clear? So let's see. Let's draw two horizontal lines perpendicular to the x-axis passing through these 2 points. You see, here, to find the distance traveled by the particle at the pth second, we need to find the rays, like the distance, the vertical distance. Okay, clean. So let's find the vertical distance. F of p y is equals to f of p minus 1. So f of p minus f of p minus 1. See, so simple equation. You see here the red line. You can observe the dark red line, right? On the axis, observe this dark red line here. If you want, we can make it even darker. And see, this dark red line is the distance traveled by the particle at pth second. Here you see the dark red line value here n there. The n value is 3.6 if p is equals to 2.21. We can change the p. If p is equals to 2.8, the n value, the distance traveled by the particle at 2.8 the second is 5. We can also change it. See, let's increase the p. The distance traveled by the particle at p is equals to 4. At pth second is 9.2. Here you can see. Okay, clean. We understood it. So it similarly came from s of n minus f of s of n minus 1. N, so that is s of n is equals to s of n minus f of n s of n minus 1. So clear, no wonder. So where did this velocity actually came from? So think of it this way. The slope of the distance time curve is velocity, which means if you the slope on the graph, this graph, if you take the slope between any 2 points on this graph, the distance, the it will account as the velocity. So let me find the slope. Okay, slope between these 2 points. I want to find the slope between these 2 points. So let's see, y2. So these 2 points are given as p minus 1 comma f of p minus 1, 1 point, p comma f of p. So y2 minus y1 by x2 minus x1. So same formula, y2 minus y1 by x2 minus x1. You see, the numerator indicates the value of n is equals to the numerator because y2 minus y1, and at the denominator the value will be 1, p minus of p minus 1. If you expand it, p cancels and minus into minus 1 plus 1. That's it. So the slope of these 2 points is equal to the distance between the vertical distance between these two things. You see, if you want, you can check these 2 points. This is the line passing through these 2 points. If you want, we can zoom it a lot deeper into it. You see, let's change the values a little so that we can play with this. See, if you want, you can see, you can also substitute the values. I'm taking acceleration is equals to minus 1.5, p is equals to 2, u is equals to, you can change the u is equals to 3, and a is equals to minus 2, and p is equals to 1 or 3. You can play with this 0.5, I'm assuming. No, it has to be equal to 1.5. You see, the distance traveled by the particle at these 2 points. You can play with this thing, but let's get back to our initial values. U is equals to 1.5 and A is equals to 0.1. P can be any number here. You see, the slope of this thing, the slope, which means the slope of the curve between these 2 points is equal to the vertical distance because the denominator is 1. You see, which means we by, let's check it here on the LHS side, the distance s there, right? It's not an direct s. Here s is divided by the change within, like the s of t into t minus t of minus t minus 1, which is 1, like s of t, which means s of nth second, which means the this s of nth value is there, right? S of nth will be, we think that we are actually calculating the distance between the length of this red line, which means the distance between these two. But with the formula, what we are actually calculating is the slope between these 2 points. These two the magnitudes of these two lines is equal, so we don't bother much. But with the formula, what we are actually calculating is the velocity, which means the slope. We are not calculating the straight line whose dimension. This here we have to divide it by, like, t, which is value is 1, which means the actual value is distance traveled by the particle at nth second. S of nth is equals to lt minus 1. S square dimensional formula is equals to, hope you